Today we're going to move into Chapter 11. The focus of Chapter 11 is area and volume of three-dimensional solids, but the first couple sections look at circles and the proper area and circumference along with the lengths of arcs and areas of sectors. Quick little calculation note, we should be able to simplify these fractions. You'll notice they're each over 360. You'll see why later in the notes. We should be able to simplify these real quickly without a calculator. And the hint is to think of what fraction of 360 is 45. In other words, if I'm going around 360 degrees, how many 45-degree increments can I break it into? All right, because 45, 90, 135, 180. There's 4 to get to 180, so there's 8 to get to 360. This is 1/8. 45 is 1/8 of 360. Here, 120 over 360, I could always simplify out the zeros first. 12 over 36 is 1/3. 120 is 1/3 of 360. When you multiply that by a whole number, here I want to multiply by 9 pi. Remember that the 3 will simplify out with the 9 to give me 3 pi. Here I have 60 over 360, which is 1/6. And again, I can simplify it out by canceling out the zeros, and then 6 over 336 is 1/6. And when I multiply that by 15 pi, 15 and 6 both have a common factor of 3. Goes into 6 2 times and 15 5 times. An answer like this I would write as 5 pi over 2. We're going to see answers that are left in terms of pi, and some of them include fractions, so just be ready for those calculations. We start with something that you should know, circumference, the distance around a circle. And a note you'll see in the examples, in the book, when they give you the number that's the radius, they draw it on, like the number goes in the middle of the radius. If they give you a value right at the center and an entire diameter is drawn, that number is the length of the diameter. Circumference is pi times diameter, or since diameter is twice the radius, we say circumference is 2 pi r. The number pi, by definition, the number pi is circumference divided by diameter. If you take this equation, divide by d, the pi is the ratio of the circumference to the diameter in any circle. One comment while doing the calculations, if you want to have an exact answer, and I often ask you for exact answers, they must be left in terms of pi. Because pi is an irrational number. It has a decimal that never ends and never repeats. There is no way to write it exactly as a decimal, so you leave it in terms of pi. So here's a little example that goes along with what we're doing with arc length. I have a bicycle wheel that has a diameter of 24 inches. I want to find the circumference. Circumference is pi times diameter. So we would say it's 24 pi inches. Now, when we're doing real problems, we usually don't leave things in terms of pi. So here, find the circumference to the nearest tenth of an inch. I would type in my calculator, 24 pi. Use the pi button on your graphing calculators. It gives you more decimal places. You get 75.4 inches. So then we want to think of the idea of how far will the bike travel if the wheel makes one revolution. Well, if I have a wheel and it's moving forward, as it goes forward, each point on the wheel, on the surface, is going to touch the ground exactly once as it goes forward. So the bike will travel the same length as the circumference as it makes one revolution. It goes 75.4 inches in one revolution. So how far will the bike travel if it makes 100 revolutions? 75.4 inches per one revolution times 100 revolutions, multiply 75.4 times 100, and you get 7,540 inches. We could also ask a question like, how many revolutions will the wheel make in 1 mile? Well, we know one revolution goes 75.4 inches. And we want to know how many revolutions it goes in 1 mile. So I need to do some unit conversions here. There's 12 inches in 1 foot. That'll cancel out my inches. There's 5,280 feet in 1 mile. That'll cancel out the feet, and I'll have revolutions per mile. And again, if we put this in the calculator, 1 times 12 times 5280 divided by 75.4, you would get approximately 840 revolutions in 1 mile. That's how many times the wheel has to spin to travel 1 mile. In Chapter 10, we discussed the measure of arc AB. The measure of arc AB, a minor arc, is defined to be equal to the measure of its central angle. So the measure of arc AB is equal to the measure of angle AOB. If this arc is x degrees, then this central angle is x degrees. And the rest of the circle would be 360 minus x. Now what we want to do is determine the length of the arc. So if we go and look at this application for a second, here I can change the radius of the circle, and I can also change the angle of the arc. So let's start with 90 degrees. There we go. Let's try and leave it right at 90. So if I want to unroll this circle, and let's make the radius 2. I'm going to unroll the circle for 90 degrees. What we see is it's traveled exactly pi is the distance. Why has that traveled pi? That's the length of the arc that was unrolled. This is a circle with radius 2. It has a circumference of 4 pi. The central angle is 90, which is a quarter of the way around the whole circle. So if I go 1/4 of the circumference, 1/4 of 4 pi is pi. And what we would expect to happen is, for example, if I double the measure of this arc to 180, I should get half of the circumference. So half of 4 pi is 2 pi is 6.28. And we could do this with any central angle. And whatever fraction of the circle that arc measure is would give me the fraction of the circumference. And one other note with this, the distance is also going to change if we change the radius. And we'll unroll it with a radius of 2. See, we go to 6. Unroll it with a radius of 3. We're going to travel further. So arc length is dependent on both the radius and the measure of the arc. We have a formula for arc length. There's 2 ways we can write it. There is no abbreviation for arc length. We say the length of arc AB. One way to write this is that the ratio of the length of the arc to the circumference of the circle is equal to the ratio of the measure of the arc to 360. This is length of the arc to total length around the whole circle equals measure of the arc to number of degrees around the whole circle. Another way to write this equation is to multiply the 2 pi r to the other side and say that the length of the arc is equal to the measure of arc AB divided by 360 times 2 pi r. In this case, the way that we're thinking about this formula is the measure of the arc over 360 is telling me what fraction of the circle I'm going around. And then I'm going to multiply that fraction by 2 pi r, the circumference. The arc length is a fraction of the distance away around the whole circle. Here, I'm going to skip a couple of these first examples to move along, but these 2 problems are ones where you would find your distances in your circumference in to the nearest hundredth because they're giving you decimal values. One note you see in this case, it's very clear that they're giving you the radius. In this case, the 21.6, when it's labeled this way next to a full diameter right by the center, that is the diameter, not the radius. Let's jump to a couple of other examples. In this one, I'm told the circumference is approximately 94 inches, and then I want to find the radius. So circumference equals 2 pi r. I would divide both sides by 2 pi to find radius. And in this case, since it says it's approximately 94, this is a problem where I'm going to round. So I type this in my calculator, and I should get about 14.96. My units are inches for length here. In this problem, it says find the exact radius of the circle where the circumference is 74 centimeters. set it up the same way. I want to solve for r, so I'm going to divide by 2 pi, but I want to leave this exact. So 74 over 2 is 37. The pi is in the diameter. I would have 37 over pi, and this one is in centimeters. This is the exact answer. There's nothing else I can do to simplify that. You will have answers that are fractions like that. Here's an arc length problem. I want to find the exact length of arc AB. Here's arc AB. It's the minor arc from A to B, where my central angle is 150, so the measure of that arc is 150. I take the fraction of the circle. This is 150 out of the total 360 degrees times 2 pi r. 150 over 360 is 15 over 36. I can simplify this without a calculator because 2 times 18 is 36, and I have 36 in the denominator. That's all going to cancel out, and I'm going to be left with 15 pi. It's a distance, it's inches. In this case, if it says exact, leave it in terms of pi, as opposed to this problem where it says to round to the nearest hundredth. So in this case, I would take the measure of the arc over 360 times 2 pi r, and I would just type all this in my calculator to get 2 pi, times 2 pi r is what I'm trying to find, times 2 pi r equals 14.2. I've been given the arc length. I want to solve for r. I would take this, I would multiply by 360, divide by 132, and divide by 2 pi, and I should get a radius of 6.16 inches. The examples can get a little more complicated. Here we want to find the perimeter of each region. I'm just going to look at this one quickly. Here we have these tangent segments joining each pair of circles. So if I want to find the perimeter, I want to find the distance all the way around. There's 3 of the So here we have the 3 straight lengths that are each 6, and then we want to find the measures of these arcs. Now we need to remember some things from our previous chapter here, including that when you draw a radius to a point of tangency, it's always perpendicular. So if I go around this diagram and I connect the center of each circle out to the point of tangency, and then I connect on the inside, what I have are 3 rectangles, and then in the inside, these would all be 6. This is an equilateral triangle. So if these angles are 90 and 90, and then this is an equilateral triangle, so that angle is 60, this arc measure has to be 120 degrees. And the 6 centimeters includes 2 radii of these circles, so each radius must be 3. So I have 3 arcs, each that are 120 out of the total 360, which means if I have 3 of them, I have a total of 360 out of 360. If I put these 3 arcs together, I would get one full circle with a radius of 3. So I'm going to add 2 pi times the radius, which is 3. 3 times 6 is 18, and then here I would have plus 6 pi, and this is centimeters, and that is my final answer. You cannot combine an 18 and a 6 pi because they are not like terms. So there will be problems where you have to add some straight segments along with some of the arcs.